This meeting is being recorded.
Okay. Sorry. Sorry, we started recording, but can you see my screen? No, apparently not.
Yeah, we could see your screen for a minute, then I think we saw the Zoom window, and then you stopped sharing again.
Yeah, I don't know. Sorry. Hello, okay. So can you see the screen now? It should be a single window.
Yes, the end video.
I'm not sure whether you're seeing it now.
We saw the end video login screen.
Yes. Okay, let's get started. It will be easy to edit. Okay, so today I'd like to present you the simulator from NVIDIA called ISAC, or ISAC Sim actually, okay? And it's a bit in a kind of series on, we started with a Unity simulator the past few weeks. So a lot in common with Unity, but there are also quite interesting differences that that we can review quickly. And so part of it is that there is this thing that NVIDIA called the Omniverse. Okay, so Omniverse is actually apparently a very big project because I read a bit of documentation and it's significant. They talk about many things. Okay, and here we'll be talking just about the simulator for robotics called ISAC, part of this Omniverse thing. Okay, but to be honest, by reading more about it, I can see more what they're trying to do. Okay, and so maybe something interesting to talk about, because there is direct link with robotics and so with what we're doing. Okay, so here on this is a remote machine that I can give access to if you're interested. The only particularity of this machine is that it's running on Linux and it has NVIDIA GPU, of course, which is an RTX 2080 Ti. Okay, so not very recent, but it's a bit better than the minimum requirement to run this simulator, and it's relatively heavy. So let's see how it goes through the network. Okay, just for information. Okay, there is something that runs in the background. It's called a ROS core. Okay, so ROS core is a part of the ROS, the operating system. Okay, the robot operating system, and we have that runs on the background, and will be used by interfacing with the simulator as we did with Unity. Okay. I also need to launch the simulator itself. Okay. So just a technicality. Okay. Where is it? Sorry, the demo was completely ready before we start, but I had a power cut and I had to restart everything.
I think it's interesting to see what you need to do in order to get it running, because we'll have to do that too one day.
Oh yes, but I like also to start with a demo straight to the point, and after we get back to we can get back to the detail depending on the interest. So anyway, happy situation. So this is the main interface of ISAC. Okay, so if you remember what we see on Unity, is very similar. Okay, so you have a main space, and after we have different objects and facilities. Also here you can see a reference to the GeForce board that is used. Okay. There is also something here, the FPS, so the frame per second, and it's almost 120. I think the setting is 120. And so in my trials, it's too much for this GPU. Okay, so let's see what it gives. Okay, so here I will be using. Okay, so sorry, everything was ready, but now what was it? compared to Unity, there is something that I will be a very bad ambassador today to show you that it feels like Unity is not really committed to robotics. Okay, there is Unity for game development, and they did some extension for ROS. Okay, but it's pretty shy. Okay, and apparently also not very much supported. Isaac is very different. Okay, that you see, you have here the plain Isaac, and inside you have import robots, you have ROS demos, and so on. Several utilities that are specific to robotics that are out of the box, like what is called an UIDF importer. So UIDF, is the file format for the body of robots. Okay. And so there are several things that are included out of the box. I will try now out of memory to make it work. So you see, I selected a navigation example in ROS. Okay, so it takes a lot of time to run, to load on this machine. Okay, okay. So now we get it here. Okay, I will try to make that a bit more visible. Sorry. So this scenario is what's called a warehouse. Okay, when you have forklift and boxes. Okay, like that, and you have the robot here. There's something else is that also it's the way to interact with it is slightly different and less natural for me than Unity. Okay, so you can see the robot here. It's this one. The name is I think is in here. It's Carter. It's Carter. So it's a rover with 2 wheels. Okay, and if we start the simulation, we can see the view from this robot. So this robot is in front of the carbon box, and we can see that here. Okay, that's the view from the camera. So if I restore the perspective, okay, so we have 2 things here. We have Isaac, okay, with this scenario with a warehouse and a robot ready to act. We have a ROS core because this is I'm using here ROS 1 because the operating system is a bit older, and it's ready to act. Okay, what is missing is the controller of the robot. Okay, so for that it's so the controller is basically the header. Okay. Okay. Is it enough? No. So sorry. So I need to get to what is called the workspace. Okay, in ROS. Okay, so. And what is nice is that everything here that I'm showing today is shared, is packaged with Isaac. Okay, so everything is available to make the demos, to modify them, with or without. There are examples with or without ROS. Okay.
What do you mean without ROS?
Because there are examples that do simulation without ROS itself, basically. So robotics doesn't assume ROS. Okay, it's popular choice, but it doesn't assume it, right? Okay, so here we go. Now we've got the. So very similar to the Unity demo. This one starts also RVs. So RVs is the visualization part of the ROS ecosystem. Okay, so for the moment we just see the robot without rendering at all inside the environment, And this is by starting the demo, starting here. By starting here, basically all the ROS topics, okay, all the data streams get started, okay. And so you see now it updated automatically. We can see the view from the robots, and we can see the world as seen by the robots, okay. And the robot itself also is rendered here. And very similarly to the demo we had before, we can set a goal, okay, and we can see automatically the thing happening in this 3D environment.
Why is it rendering it in two places?
So just for sake of demo, okay. So there is one thing is that so it's rendering in Isaac because this is the fully fledged software from NVIDIA, so it can leverage the board and so on very well. Okay, so it's a photorealistic kind of situation. Arviz is a familiar for people in robotics. Okay, and the thing also is that there is this interactive part that looks like really part of Arviz. While on Isaac, it's more work. Okay, I wanted to present a tutorial where that was without Arviz, just with Isaac, because we can make some control, you know, like a virtual joystick, basically. At this point, I haven't managed to make it work entirely. Okay, so that's why this relies on Arviz. But retrospectively, it's also what I presented with Unity a few weeks ago. So I thought that people were getting familiar with the messy settings to demo. Okay, so it's not a great reason, but it's well, it's a discovery attempt here. So that's basically very similar to what we discussed with Unity. Okay, and that's about it. A few remarks, and after another point, more interesting this time. So a few remarks is that really, it looks like NVIDIA is committed to this. Okay, the documentation is really well detailed, is up to date. There are a few quicks here and there, so I took quite a few notes. So if you're interested, I can share that. I will share it sooner or later. Okay, but if you want to try it by yourself, it's you know, a few things change, some path change, and it always takes time to follow a tutorial where things are unknown and suddenly a path is different, basically. Okay, but otherwise it felt if it's much more active and much more commitment from NVIDIA into this ecosystem. So I'm talking about Isaac and robotics, so ROS in particular. I can't say much about the Omniverse, okay? A quick word about the Omniverse, okay? So there is, basically to get started, you have to install this, okay? Some kind of app, they call that the Omniverse app, okay? And I forgot my password, so I won't try to log in again, sorry. It's like the Unity hub in some sense, okay, but it looks like much more than that, okay. So there is a lot about metaverse kind of thing, but the integration is really good, honestly, okay, with Isaac, Omniverse, and so on. So Isaac is really about the simulation, but through Isaac we can access assets, okay. So like the asset store in the Unity, and that works really well, okay. So that works really well, and it really looks like NVIDIA is investing on it, okay. So you can see the robot dog that I haven't tried yet, and some others that show up. So to create an environment in Isaac is well integrated, okay. We see that there was an effort to make it accessible, okay. Also, we still have to set up an account and so on, okay, but it looks like easier on the license side as well. Another aspect is that you know, when we look at the what it is, To download Isaac, you have to go through Omniverse, okay? So it's just push buttons and so on. But once it's done, okay, you get this, okay? And so inside this, we can see a lot of scripts, okay, with different scenarios. You can run Isaac in a headless mode on a WebSocket, WebRTC, native, on Docker with a GUI, and so on, okay? So there is a default. I don't know whether you ever tried to install an NVIDIA GPU, but it used to be a pain, honestly, okay? At least on Linux, okay? I don't remember doing it on Windows, okay? And recently, they started to use package managers and so on in a more streamlined way, but it's recent, okay? I mean, it's not even 2 years old, okay? But here with Isaac, we see a lot of developer-ready things, okay? And these are scripts you can read, okay? So we know exactly what it's doing. And also, it looks like, I don't know about the license, but it's, I'm interested in using these simulators headless in containers and on the cloud, basically. And it looks like it's much more easy here, okay? Also, the Docker containers are already provided and so on. Docker providers that use GPUs directly and so on. So it's a lot of work that apparently NVIDIA is doing, so really committing and invested again on that, okay? For example, such kind of screen may not talk too much to you, okay? But the thing is that there is no equivalent in Unity, for example, okay? In Gazebo, yes, because it's open source, so everything is accessible anyway, okay? But honestly, I'm very nicely surprised because I was not expecting that from NVIDIA, okay? So that feels good. So,
Eric,
yes, please.
do I need to have an NVIDIA card in order to run Isaac?
Yes. So the minimum, so you see here, I have an NVIDIA GeForce RTX 2080 Ti, okay? So according to the documentation, the minimum requirement is RTX 2070. And so RTX 2070, if I'm not mistaken, it's a 5-year-old board, okay? So 5-year-old is kind of honest, okay? And I think it must be RTX because RT means ray tracing, and it's heavily relying on ray tracing apparently, okay? So yes, you need an NVIDIA board to use Isaac, okay? And so, business-wise, that makes sense because we can imagine that how NVIDIA makes money is by selling cars, basically. So for me, what is more positive than I was expected, way more positive, is that this time they really took care, they are really taking care of the software, so making it useful, maybe a good market fit, and also relatively pleasant to use, okay? And so obviously it's to sell the hardware, okay? But then I'm fine because feels like with the software, they're really taking care of the people who are going to use it, basically. I didn't have that feeling when I'm still installing the drivers, but which is weird. Any question? Because I moved to the next and last point. That is more specific to Isaac. No. So I wanted to show you an interesting thing is that inside. So you can create a lot of things, okay? But there is something called visual scripting, okay? And I just use Action Graph for that, okay? And so if you're familiar with LabVIEW, from what are the company National Instruments? I don't remember. Having used that for forever, okay? But you have anyway. These days it's called a no code stuff, okay? And apparently they are doing that, okay? Is that an action graph, basically, that you have a bunch of nodes, okay? It's well, there was a timer, I think. No, what was the name? Ticker. Basically, it's a drag and drop. Yeah. So on playback tick, okay. So you put a box like that, and so you see it's a component. Okay. Behind it is going to be a software component. Okay. But this one is it will generate ticks. Okay. ticks, is typically when you have something like a microcontroller, you have a clock, basically, okay? And after we have what's the publisher? Yes. So the tutorial I did was using a robot where we had a publisher as a subscriber, okay? And so, we choose our components like that. So it takes a bit of, I did the tutorial, I'm showing you, and did it only once, okay? So it's out of memory, but it's kind of working well, okay? And so, what was it? Yeah. And so after, it's just like that. You connect the components, okay? So we want a common clock for these two components, okay? And we can put more components. Okay? And after we need more components to have something compelling, okay? But once we put them, we have a graph we can navigate, we can debug, and we can debug, and after we just press the play button, and it will just run almost magically, okay? So the code is generated behind it, and that just works, okay? And so this, I think that's really cool, okay? Because of two things, is that it's a big environment with many things, okay? But when we have also an external code editor, it's like our mind has to switch to hear a visual world where it's more like a clear world where we can play with our hands, to another world where it's based on text. Okay, so this swapping, at least to me, is really tiring and inefficient. Okay? And in many scenarios, basically we drawing a graph like that just makes a lot of sense and it's pretty smooth. Okay? We are in one world and we stay here. Okay? The other reason is that recently I see that something called behavior trees are popular. Okay? Behavior trees is basically a graphical. So it's usually a tree. Yes, I don't think it can be a graph. Okay, a general graph. It's a tree. Okay. That you can program in C++ and Python. Okay, especially the ROS ecosystem has both kind of libraries. They look like being used more and more. Okay, a lot of demos. The Unity demo had a behavior tree integrated. Okay, here too. And the thing is that these are trees like that. Okay, so it's usually these libraries are, you write the code, okay, but after you can use GraphWiz and dots to generate the tree, okay. But here it's upside down, okay. It's a no-code approach, and that leads to a behavior tree, and which is apparently pretty popular in the community, okay. And so that's very in line with my earlier comment to say that it seems that NVIDIA is betting on their Omniverse and Isaac. So they are betting and really committed to make something work well. Okay. So any question on this action graph, okay, which is basically a kind of no-code approach to make the software controller for the robots?
Yeah, did they tie this into any type of AI, image recognition, or that you can mark up a plan and then it turns it into command, any type of automated process using AI?
Yes, and so thank you. That's excellent because I completely forgot. So there are several tutorials, I mean, on the documentation on reinforcement learning. Okay, so I didn't have time to cover them, but they have quite some content based on that. Okay, so yes, okay, but this is also where the Omniverse thing somewhat starts to make sense, in terms of how consistent it can be. Okay, so here is quite good. I was almost about to say excellent documentation. Okay. Okay, so see, you've got such kind of so it's Omniverse, but here is a complete section, dedicated to Isaac. Okay, and there are many topics. It's well detailed, good screenshots, usually the good links. ROS1 tutorial, ROS2 tutorials. I don't remember. I think I read about Cortex, but I can't tell you what it is. But you see, they talk about behavior examples and so on. So, but where is the one I wanted to talk? So, in passing, you can script in Python and with you can work with Python scripting directly, okay, and with notebooks, Jupyter notebooks, okay, which is popular with people doing machine learning and so on. And sorry, what is it? And there is a whole section about, I'm sorry, about reinforcement learning, which I may be able to find one day, okay. Maybe the gym tutorial, yes. So gym refers to a library that was created by OpenAI. Okay, it's a very simple API actually. Okay, that I think you can see here basically. Render, close, seed, step, resets. I think it's that's it. That's all. It just defines an API basically. After there is an implementation in Python because it's the most popular language probably. Okay, and there is a default implementation that does nothing. And it's an API, the Gym API, that has been adopted by many libraries and many tools in the machine learning world. Okay, and here again, NVIDIA integrates it like out of the box basically. Okay, so we can do machine learning directly into Isaac by using this standard API. So sorry, I haven't reviewed this in detail, but here is a typical example. Okay, it's called the inverse cat pole. Okay, so inverse cat pole, it's when working on automation and industrial automation and so on, it's or also cybernetics and so on. It's a very typical example in which you have a pole that is on a rail. Okay, so it's just 1 degree of freedom. Okay, it can just go left and right. Okay, and it's on wheel. Okay, on the rail, so it can move. Okay, but also it has a pole. The pole is just something. It's just a stick pending. Okay, but maybe you know this game is that if you move right, you can get the pole up, and you can keep it up like that. Okay. And so this is a very common scenario in reinforcement learning, okay, is that we create a small piece of software, we call it the agent, and we want this agent to learn the cat pole game on its own, okay? And so here you have a demo that is actually, doesn't look great like that, but you can see there are many of them, okay? In fact, I think they are pitching the fact that thanks to their fast GPUs and so on, they can train many agents at the same time. Okay, I don't remember many, but it's quite a few. Okay, and so why it's relevant, because when you can train many agents at the same time, you can learn more. Okay, because after you can synthesize all the experience of each of these agents and build a super agent. Okay? And so if you're NVIDIA and you want to sell a lot of GPUs, that's great, because if people buy 10 GPUs to run many more of these agents at the same time to get faster at what they want to do, it's a win-win for everyone, basically. Okay. So yes, there is a clear commitment to integration with the machine learning. Okay. In the Isaac, so the Omniverse ecosystem.
Eric, there was one thing that I didn't quite understand. This is all running on your computer, or some of it is running on the cloud?
No, everything is on the computer. Okay, it's a single computer. So here you have Isaac. Okay, you have Isaac. You have a ROS core. You have the ROS software for the two-wheel rover in the demo. Everything is there. Okay.
So it's
So-
communicating with the Isaac sim with some socket. Right.
Sorry, I couldn't get a socket. Sorry.
Yeah, so like the ROS, how is it communicating with the Isaac sim, the simulator?
Okay, so it's very similar to what we saw in Unity. Okay, it's they have something called the ROS bridge. Okay, so in Unity it's the ROS TCP connector, and here it's called the ROS bridge. So where was it? Maybe tools.
I mean, ultimately, it's pub sub between the ROS nodes running in Isaac and then the controller ROS nodes, right?
Yes. So we have Isaac that run the simulator and this ROS bridge. Okay, and here I studied earlier this. So this is the ROS controller. Okay, so it was this command, ROS launch, and the cutter with the navigation stack. Does it answer your question, Anuraj?
Yeah.
Yes. And so in Unity, it's a TCP connection between both. Okay. Here, I didn't get the detail. Okay. But it's very likely. No. It's I saw that there were UDP packets that were sent. Okay. And so it's at least UDP. Okay. But anyway, UDP TCP is pretty cool because then you know a bit what the question from Meyer is that we can run the stuff on different machines. Because with TCP UDP, it's really easy to do some networking. Okay. And for me, that's a good news because I'd like to use the simulators headless. So headless and remotely, typically. Okay. Here, I'm doing everything on a single machine first to show that it works. Okay, with a 5-year-old GPU, and it works on a single machine, so we can get started pretty easily. Okay, it's these are big ecosystems, so I think it's important to be able to do that. Otherwise, it's just a lot of work to figure it out, basically. Would there be any question? Because we have 10 minutes left, and so maybe we can talk about what Venkatesh suggested, a bit more meta discussion.
I don't think 10 minutes is enough for that, so maybe we should just defer that to next week, and maybe we can take the last 10 minutes here to talk more about this stuff. I did have one question, not about this ROS module you were just talking about, but the actual models that seem to come, or environment models that Isaac and Omniverse offer, are they like modeled 3D model, like game engine type environments where, for example, this forklift truck is like modeled object, or can it also do things like those 3D scanner type cameras that can take 3D scans of a room, and then you can load that into this? It won't have all the details of like, that's a table with these properties and so on, but it'll have all the like geometry. Can it handle that kind of thing, either this or Unity?
So first, I just can't answer. I just don't know. Okay. So I'm just speculating flexible, and actually that's what they want. Okay, because they, you know, especially in ISAC, they have, I think they have anyway much better on many aspects. Okay, but this integration with assets. Okay, and so I think they understand that a limiting factor for adopting simulation in making robots is these assets. Okay, so the availability of objects, things we can use, we can modify, we can iterate on. Okay, just to create the worlds we need to make demos. Okay, but also because if we take something like reinforcement learning, you know, we need to generate a lot of scenarios. So we need a forklift that is yellow or green or big or small, 4 wheels, 3 wheels, and so on. Okay, so if we have a parameterized models, so not only models but parameterized models, it's a big win for the customers, so big win for the company. Okay, so I was trying to see whether this forklift is a 3D model or just a rendering, but I think it's a 3D model. It's just that for some reason. Yep, please.
Is part of what you're asking, Venkatesh, about the actual rigging of the object, because that's a big piece of the URDF format.
I'm actually getting at application deployment. Let's say I have a robot that has like some reinforcement learning and other kinds of training already attached to it that comes from the manufacturer, and I want to deploy it in my specific warehouse. I would assume the most intuitive and natural way to do this is to just walk into the warehouse with my iPad, which has that 3D scanning capability. I think the latest iPads have that LiDAR-like thing or whatever it is that they use. But yeah, just, you know, twirl around in the warehouse, build a 3D, it's not a 3D model, but a 3D scan of the actual operating environment, load it into the robot in some form, and then it can apply its training and recognize that the real forklift I have in my warehouse that has just been scanned is kind of like the modeled forklift available from the library, and maybe it loads it up or something, I don't know. But I guess what I'm getting at is this level of modeling and simulation is kind of part of the training side of robotic control models. And then there's the equivalent of the inference side, which is like the actual operating environment, which you have to like map and capture, including things that are not in the asset database and you don't particularly want to. Like maybe I have like a very unique wooden table and it doesn't do much. I don't care whether it's modeled as an asset in the library or not. I just want to make sure my robot knows that in this particular robot, that particular table exists. Does this make sense now? The question?
Yeah, in terms of just the workflow in a practical application for site survey and previs. I know that yes, 100% you can import scans into Isaac. I just haven't personally done it, but I know this is very much specifically from like a laser scanner, because a lot of these surveys wouldn't be like an iPad photogrammetry thing. It would actually be like architecture firms and all these. They use like a Leica scanner, like a LiDAR with color.
Okay.
And all of those scanners do spit out a format that can be ingested as an asset, and you would pull it in.
Okay, that's what I was getting at. So it's like there's a whole separate workflow and environment modeling that's like scanning as one input pathway, and another input pathway would be building like a model in a CAD tool and maybe parameterizing it for variation. So there's two pathways to actually creating assets, the real world and then actual designer tools, and then both get integrated into a database. And I guess what exists in the available database will be things that are all the way from like fully rigged and animated models whose properties are like very close to the real world ones. And at the other extreme of dynamic fidelity, you have basically a 3D scan, but without like further analysis, you don't know whether it's a moving robot or a table. So it's like there's some complexity here in how you get to the environments, whether for application use or for training use.
Another important thing, the distinction though is remember there's either sort of like a parametric or so there's like meshes, parametric, and then like point clouds. And so URDF, I want to say, I'm pretty sure URDF is a mesh format for the 3D. So it's like an OBJ, but URDF specifically also supports rigging, which for like, let's say you wanted to put the spot robot in your warehouse that you just scanned with your Leica, you need that URDF to come in and be rigged with all the joints already. Otherwise, you're going to have to do that yourself, which is very non-starter, time consuming and repeated work. So you want the vendor to have a URDF that's going to come in and be rigged and ready to go.
Yes, indeed. Indeed. URDF looks like what all these simulators are trying to do at first. Okay, at minimum, they Unity, ISAC, but several others, they have a URDF importer. URDF is basically an XML file, okay, that defines a lot of what Joshua said about basically the wireframe, okay, and after some other properties. On the scanning part, it turns out that 1 year ago, Fabian and I, we wanted to try that, and we started this week. Okay, so what we're doing right now is just an experiment to see how we can introduce an arbitrary object inside a scene like that. Okay, and so right now it's very basic, and we are just using a recent smartphone with the lidar. Okay, and I think we also have an iPad that can do that. Okay, and so what we're doing basically is what I have tried. Okay, is I have a small office. Okay, in this office, I just sit in the middle on a turning chair. Okay, and I turn myself with the iPad and scan the whole thing. Okay, and that works pretty well. Get a nice point cloud. Okay, with texture as well. Okay. Now there is some work to do on segmentation to identify what is what. Okay, but basically with that, conceptually, we can go as far as, for example, the forklift. You know, if we find a forklift model that we don't have and we need the simulation, okay, I would turn around with, for example, an iPad pipeline to segment it out and put colors and so on. Okay, but it's an experiment we started this week, so we may have something to show in soon, basically.
That is cool.
I was just going to say, I'd also be happy. It's something I've needed to do for a long time. So the thing about URDFs, everybody's going to ask, okay, how do you get out of, because all of these robots and forklifts and things were designed by humans in a software. So do those software speak URDF? And the answer is sort of. There's a bunch of, generally, because it's like kind of the ROS and robotics world that wants URDF. So specifically, there's like I think it's an open source tool for SolidWorks that allows it to spit out URDF. And then there's some GitHub, I specifically noticed, I've dealt with this recently, is there's this GitHub repository of some university that has an Onshape URDF exporter. But you have to like kind of do some weird stuff in the model for the exporter to work correctly, for the rigging to be correct. So I'd also be happy to dig into that a little bit and talk about that next week if somebody wants to see an Onshape to URDF export.
That's something I would definitely like to see, because Onshape, I think, is one of the few tools I've gotten far enough along in that I think I could actually get somewhere with this tool. Like I was just looking up URDF and I was thinking I'd have to like write code to generate it from like Python or MATLAB. That seems like a really painful thing to do, but if it can go directly from a CAD tool, perfect. Yeah.
That would be great. And I'd like to add to what Venkatesh said is that we see there is a very close relationship between between URDF and CAD. Okay, so we have Onshape, and if Turtleboat, so it's the boat I was using in Unity, and I wanted to use here. If you go to the Turtleboat manual, at some point you can open everything is available is on Onshape basically. Okay, I think it's here. Everything is open source for the Turtleboat, and they have all the 3D models. So sorry, I don't remember where it was. Sorry. I was surprised when I clicked on I wanted to see the CAD. Okay, boom, it opened on Shape, and everything is there. Okay, so you can completely hack or customize the design. Okay, so it would be interesting to see the more explicitly, Joshua, from what you do, also the link with CAD. Okay, and my last point is that also it's about this omniverse stuff in NVIDIA. Okay, they don't have something like on Shape. Okay, but everything looks connected somewhere. Okay, so I don't know what they want to do exactly with this omniverse, but that's also part of their story in some of the documents I read in this review.
Neither do they. They're also figuring it out.
Yes.
I wanted to ask the opposite question, perhaps. Can you generate URDS format from DALI or Stable Diffusion or one of those programs? It's not as funny as it seems, because we want to generate worlds to work in. We might as well have an AI generate them.
Oh yeah, it's going to happen.
Especially
I already see people doing prompts that generate pretty good looking 3D like science fiction robot models. And I think like with a little more work in a couple of years, we'll see that being possible. Like even if it's close to mechanically realistic, you can like fill in the gap and make it actually realistic and like produce it. I think I already saw some artists 3D printing like static objects based on things produced by Stable Diffusion, at least. I don't know about DALI. DALI seems less capable now compared to Stable Diffusion. Yeah. All right, we're just past the hour. So for next week, Joshua, do you think you'll be able to do the on-shape and whatever, what did you call it? RD, whatever the format is?
There's an on-shape to URDF plugin. Yes, I'll be in Eastern time.
Okay, so why don't we schedule that for next week, and then the week after we can do our strategy deep dive, because looks like we have some momentum in the simulation direction to quit. All right.
That's great. Thank you.
All right, thanks.